This example gives us f of t equals 1 over the square root of t and asks us to find the derivative of that using the limit definition of the derivative. So let's recall the limit definition of the derivative. The limit as h goes to 0 of f of x plus h minus f of x all over h. Again, a good thing to set to memory. Okay, so plugging into the limit, we have, let's see, so let's do this, f prime of t in this case. Okay, it's the limit. It's not t going to 0, it's always h going to 0. Some people tend to put, the variable here, t or x, but it's always h. Let's see, 1 over the square root of t plus h minus 1 over the square root of t all over h. Let's get a common denominator here. So how about limit as h goes to 0. I'm thinking a common denominator, we'll say LCD of square root of t, square root of t plus h. And you can see that this is going to become complicated quickly. So we hit this with our LCD, we have square root of t over square root of t. Over here on the right we have a square root of t plus h over the square root of t plus h. A little messy there. This becomes the limit as h goes to 0 of square root of t minus the square root of t plus h all over h square root of t plus h times square root of t. And you may be saying, how did that h get down there? Well, remember, a over b all over c, the fraction bumps down one layer, a over bc. So this denominator that were created kind of bumped down one level to be right next to the h down there. So we just have one denominator to worry about. How do we proceed from here? Just take a few seconds and see if you know the next step. Pause the video if you need to, and just look at this for a minute and see if you can figure out how in the world to get rid of that h in the denominator. Remember, here we want to get rid of this h because we're letting h go to 0. How do we do it? It turns out that the conjugate is helpful here. The conjugate is where we take something and change the sign and multiply. So here we'd have the square root of t plus the square root of t plus h over, we have to repeat the same thing down below because we're just multiplying by 1 here. So this is known as the conjugate trick. And it's super useful in math, especially when you're not quite sure how to proceed. Hey, try the conjugate. It often works. Because look what it does to the numerator when we FOIL that together. We have the limit as h goes to 0. The numerator now becomes t minus parentheses t plus h. Look at that. Now, the denominator is a disaster. I'm not going to deny that. But we have cleaned up the numerator substantially. So in the denominator, we have h times the square root of t plus h times the square root of t times the quantity square root of t plus square root of t plus h. So don't lose faith just yet. Look what happens in the numerator. The t's cancel, and we're left with negative h, but then this h will cancel with the h in the denominator. So what do we have? We now have just a single limit, the limit as h goes to 0 of negative 1 over, and then, yes, we have a bunch of stuff. Square root of t plus h, square root of t times, again, parentheses t plus square root of t plus h. I don't even know if I said all that right, but you get the idea. But now we can evaluate this limit without getting a 0 in the denominator. Right? We can essentially plug in 0 for h, and look what we get. So we're evaluating the limit now, so the limit goes away. Once you evaluate the limit, you don't write limit anymore. We just have square root of t times square root of t, parentheses, square root of t plus square root of t. There's a very compact way of writing this answer here, so let's look at that. Negative 1 over, I'm going to write this as square root of t squared times 2 square root of t. Now I'm going to combine those t's, so this gives us negative 1 over 2 square root of t cubed which we'll then write as negative 1 over 2t to the 3 halves. And that's kind of our standard way of writing the solution to this. Well, you may be saying, wouldn't it be easier to just write this as t, square root of t times square root of t? But it wouldn't just be t. It would actually be absolute value of t, and then suddenly you have absolute values in your answer, and that's perfectly fine, but it's a little simpler to just leave it in this form and just keep it in a nice exponential notation, negative 1 over 2 t to the 3 halves. Also, once we get our rules for differentiation that will allow us to skip this entire process, this is what the answer will look like. So it's good to get used to seeing answers in this form.